And welcome back, Mindsetters. Hope you guys have your notes and pads out and you're ready to make more notes because we're back and and I hope that you guys have done whatever you've had to do. You've gone and left whatever you had to do, and if you're cutting onions, you cut them later. Whatever you had to do, now you need to be paying attention. Get your pens and pads out and ready to make notes. Because right now I'm going to hand back to Phil, who's going to continue the rest of the session. Phil, take it away.
Thanks so much. Okay, well, we're going through this a little bit slower than I'd planned, but the really nice thing is it seems that you guys are really enjoying the page and enjoying those packs that we put up there. Keep answering those questions. We've gone all the way through to question 5. Now, it's my aim to get through question 3 because I've seen a version of question 3 in every single final paper. Look for something like this because they really, really dig this type of question. And guys, please, you'd be silly not to do this because I've seen a version of this in every single final paper for the last 5 years. Okay, so now watch carefully. The reason that they like it so much is because there's this problem in the thinking that people have got. Okay, so now the classic question goes as such. I've got a hot air balloon is moving vertically upwards, okay, at a constant speed. Now that's pretty important as well. Okay, so it's moving upwards with a constant speed. A camera is accidentally dropped from the balloon. Okay, now this is where people really fall apart. Okay, accidentally dropped from the balloon. And they tell me that it's from a height of 92.4, as shown in the diagram. The camera strikes the ground after 6 seconds. Ignore the effects of friction. Okay, now in my mind and in your mind, what happens when you drop something? Okay, well, I find something, and as soon as I let it go, it starts to go downwards. So what I've got to do is I've got to realize is that now this camera was not dropped from a stationary position like I dropped this. I didn't drop the camera from a stationary point. If I was moving upwards while I dropped this, now dropping just means letting go. So what happens? I just let go. But now the strange thing was that my hand and my pen were moving together. Now what happens is when those let go of each other, the pen is not going to immediately start falling. Please, just get that into your minds. Guys, think your way through this. I know that your brain wants to resist this. So if an object is moving upwards and it detaches from another object, they both continue to move upwards. However, the one that becomes detached is going to start falling under the influence of gravity eventually. It'll slow down, stop, and eventually come back down to Earth. But now I want you to think about this so carefully because the first question asked me about that. It says, at the instant the camera is dropped, it moves upwards. They tell us it moves upwards. You cannot fight with these examiners. They know what they're talking about. It still continues to move upwards. Give a reason for this observation. So we're going to do this one quickly descriptively. The reason that the camera still moves upwards is because of Newton's first law. What happens is that an object will continue in a state of motion. It had inertia. It will continue to move. Eventually what happens is gravity will slow it down and it'll stop, it'll turn around and start coming back down. Okay, but please, the camera has got inertia. So it's not just going to suddenly stop dead and start falling. It was moving upwards with the balloon. So that's what you can say, is that the camera was moving with the balloon. It was moving upwards initially. It's not just going to suddenly stop. That's impossible. Okay, now 3.2 is where I place my interest. Now it says to calculate the speed, okay? VI. Now the reason that they've chosen the word speed is because you don't really need a direction, but they have called it V for velocity. So what they're saying when they say speed is you don't have to give a direction, at which the balloon is rising when the camera is dropped. Okay, well what we've got to figure out is if I've got my little camera over there, and there it is. So there's my little camera. My camera continued to move upwards, and eventually it's going to fall all the way back down my 92.4 meters. Okay, I know a whole bunch of information about that, but what I've done is I've done the first step in doing my equations of motion. DDTE, diagram, direction, table, equation. So what I'm going to do is diagram first. So I've drawn my diagram here. I've drawn what I think is going to happen. I always draw pictures. I cannot do physics without pictures. So diagram first. Then I'm going to choose a positive direction. So what I'm going to do is I'm going to say that up is positive because I know that my answer is an upwards one. I knew that the camera was moving upwards. So I want my answer to come out nice and positive. So I've chosen up as positive. There is no such thing that the down or the up is always positive. Don't do that to yourself. Understand that you choose the positive direction. Stick with it. So there it is. Diagram, direction. So there's my first two Ds, diagram and direction. Now what I'm going to do is I'm going to do a table of what I've got. Okay? And VV, so V initial, V final, TAY, so VV Tay. There we go. So my initial velocity, which I'm looking for, let's make a shopping list. Let's see what I got. Okay, well, my V initial, that's the question mark. That's the one that I'm after. My final velocity, don't know, don't actually care because they didn't ask me. So what I can do is temporarily I can cross VF off my list. I don't know how fast it hit the ground. They didn't ask me how fast it hit the ground, so I can ignore it for now. However, they did tell me that the time was 6 seconds. Acceleration, now this one's quite tricky. Do I know the acceleration? Well, I know that this object is under the influence of gravity the minute I let it go. So that means 9,8 meters per second. But what I've done is I've made a mistake. And this is a mistake that you guys often make. I've forgotten about my directions. Acceleration is due to gravity, and gravity pulls downwards. Even though the object is not moving downwards, you can have an acceleration in that direction. Now let me just repeat that. You can have an acceleration in a direction that you're not moving in. How can that be? One of the ways that you can think about this is if acceleration is in a different direction to your motion, that means that you're slowing down. Okay, last piece of the puzzle, my displacement is negative 92.4 meters. Now, how can I say that it's negative 92.4? Well, that's also downwards. The camera is going to land further down than it was up. I now have my information. What I've now got to do is my last step, is my equation. If I've done these 3 steps, I don't have any marks yet. But these 3 steps ensure that I choose the right equation and that I use it correctly as well. So what I'm going to do is I'm not going to go around and say, okay, well, I need an equation which has got VI and delta T and A and delta Y. You're going to waste a lot of time. There is an easier way to do this. What you've got to do is find the equation without VF. So that's much, much easier. You can just look through an equation. Oh, there's no VF. Okay, now I've got a way to go forward. So let's do 3.2 together. Okay, so now we may not get a time to go through all of this, but 3.2 is something that I really want to stop and focus on. Okay, so the only equation which doesn't have VF in it is the one which starts out with my change in displacement is equal to VI delta T, okay, plus a half A delta T squared. Okay? So now what I'm going to do is I'm going to substitute in what I've got and see what comes out. So now I know that my displacement is equal to negative 92.4. So there it is. Don't forget the signs because the signs are more often than not the problem. So VI and then delta T was 6 seconds plus a half. Negative 9.8 is my acceleration. There it is, delta T squared. Don't forget my delta. There we go. All right, we've forgotten to fill in my delta T. Let's just make sure that we get that right before you guys get on the page and shout at us. There we go. So 6 squared, there it is. So now what I'm going to do is I'm going to start to simplify, start to manipulate, and then I can find my VI. Okay, so let's get VI on its own. I've already got it over there. So what I'm going to do is simplify the rest of this. So I've got negative 92.4. I'm going to bring across all of this. So I'm going to have a negative half. So if I bring it right across, I'm going to have negative a half of 9.8. This is all getting a little bit messy. We're going to tidy it up using a calculator in a moment. Squared is equal to VI multiplied by 6. Oh, that's starting to hurt my head a little bit. And we've gotten out a negative. All right, so just double check that you don't drop any signs. Let's tidy it up. Let's use our calculator. Okay, so what I'm going to do is I'm going to start to enter in the left-hand side. Let's enter it in. So negative 92.4 minus, and let's put in my half. So 1 fraction 2. There we go. Putting it to the next. Don't forget negative 9.8. And don't forget that we've got 6 squared in the next bracket, another thing that everyone forgets. And that's going to get an answer which is not quite there yet. I've got 84. That's not my final answer. So I've got 84 is equal to VI multiplied by 6. What I still need to do is I still need to simplify that by dividing both sides by 6. And that'll get me an answer of 14. So I get a V initial of 14 meters per second. Now, at the end of every physics calculation, I must check to see if what I found actually matches what I expected. Well, I know, for instance, that the initial velocity of this balloon with the camera was upwards. Well, that means that the V initial must have been a positive number. Was it? Absolutely. It definitely was a positive number. Okay, I think we've got time for a very, very short question. What do you think, Ty?
I think
we
maybe
squeeze
we
it?
should squeeze it in as quickly as possible.
Okay, all right, so 3.3. Let's do some speed science. Okay, so draw a sketch graph of velocity versus time for the entire motion of the camera. Now, they want the initial velocity and the time at which it reaches the ground. Okay, well, they want a VT graph. Okay, now what I'm going to do is I'm going to keep up as positive. So here it is. There's my velocity, and there is my time. Okay, so I don't need a ruler, luckily for me. So my velocity, which is measured in meters per second, and my time, which is measured in seconds, there are my axes. I need to label them, and I need to put in my units. Okay, now I've got to be very careful about how I do this. I knew that I started out at 14 meters per second. There it is, 14 meters per second. Eventually, what's going to happen is this camera is going to slow down to a stop at 6 seconds. But now, it's going to stop way, way, way before then. I've got to not fall into the trap of thinking that it stops only on the ground. There's two places. It stops at its maximum height. Eventually, it reaches the ground 6 seconds later. So what do I put on my graph? Well, I've got to be smart about this. I know that eventually it's going to reach a point near the ground traveling at much faster than 14 meters per second, but I can't actually say without calculating. All that I know is that the velocity is going to steadily decrease through 0. That's when it changes direction and carries on downwards. So what I need to say about that point is that that point itself is 6 seconds. So 6 seconds is once it's gone all the way up. This is a place where it turned around. I need to understand this. So this is where it turned around. And then what happened is that it fell all the way down. Okay? So this is the fall. This is the downward part. So then it went up, it stopped, it turned around, and then fell all that way down, all that 92.4 meters, all that way down. So now, left with about a minute. Unfortunately, what I'm going to be doing is I'm actually going to be carrying on this particular lesson. We're going to keep on posting up those questions up to the page. Now, what I want you guys to do, start working through these, please, as many past papers as you can. By the time you walk into your final, you're going to feel like it's home again, because these questions all kind of start to look the same. So now, in this type of question, they like to give you these balloons where something detaches. I've got to remember that it's going to carry on moving upwards, stop, and then turn around. They love, love, love these questions. Expect one in your final. There is always a graph and an equation of motion question to start out all of these. There is always multiple choice. You know what to expect. These question papers are free with memos online on our website, on the Learn Extra website, or you can take a look on Sutong's website, the government's website. But what we're going to be doing is making them into bite-sized chunks for you guys. But that's it from me tonight. We're going to carry on with us for next week.
All right. So Mindsetters, Matric specifically, I hope you guys were ready. Well, I hope you guys made some notes. You guys have prepped, and I'm hoping that this pack helps you guys. Just make sure that you keep going through it. And guys, I just want to also make a quick note. There will be live sessions on Saturdays. Physical science is going to start from 10:30 until 12:30. But this is where I'm going to say see you and cheers. Liberty. Bye.